Alright, hey Algebra 2 kids. We're going to go ahead and do a linear programming example. So I gave these equations here, these inequalities, and we're going to go ahead and graph those on this graph here. And I'm going to start with the x's equal to 0, y is equal to 0. And basically what those are saying that the vertices here are part of our boundaries. Okay, so notice I did the graph just in this quadrant here because I know these are the boundaries and it's going to be greater than for both, so it's going to be over here. So I didn't have to include everything this way. Let's go back and we have to graph now this equation. Okay, we need to put that into slope-intercept form. So to do that, we have to work with this equation here. So I'm going to rewrite the 4x plus 3y is greater than or equal to 30. And I'm going to move some things around so that we can get this equation the way that we want it to. So it's going to be negative 4x plus 30. I'm going to divide by 3 on both sides. Alright, so every term here has to be divided by 3. So we're going to get y is greater than or equal to negative 4/3 x plus 10. So we have a slope, negative 4/3. We have our y-intercept 10, so we can go over here and graph this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Y-intercept, negative 4, 1, 2, 3, 4, over 3. 1, 2, 3. Right there. 1, 2, 3, 4, 1, 2, 3. Right there. Alright, so now we have that line, and I'm going to go ahead and draw that line. Give me 1 minute. Probably not a minute. Hopefully not a minute. Maybe a minute. I'm having a hard time here. There we go. Okay. There we go. Got our line. Should have connected it through more here, but we'll just see. Next, we're going to graph this line. So we have to take this equation and turn it into the slope-intercept form. Subtract x on both sides. So 3y is greater than or equal to negative x plus 21. Divide by 3. So that y is greater than or equal to negative 1/3 x plus 7. Alright, so again, now I have a y-intercept, 1, 2, 3, 4, 5, 6, 7, and a slope, down 1 over 3. Down 1 over 3. Alright, so now I'm going to go ahead and, down 1 over 3, down 1 over 3. So now I'm going to draw this line. Okay. Catch up. There we go. So, our shading spot. We're going to be greater than for here, right? So, if we are looking for greater than, we're going to be in this space, and we're going to be in this space. So that's a lot of room here. All up here is going to be where we're looking. Alright, because it's greater than for both. Up here and up here. Because we put 0, 0 in this equation here. Is 0 greater than 10? No, it's not. Put it here, is 0 greater than 7? It's not. So we're going to be all up in this space here. So above both the lines. Okay? And what I'm looking for is the minimum when C equals 5x plus 8y. Alright, so we have to think what are our vertices here. Now, we would have to go ahead and continue out this line all the way to find another vertex, which would be where this line connects with the x-axis. We're not going to do that. That's going to be kind of ridiculous here. So we're just going to go ahead with this vertex here and this vertex here, minimum and maximum. And we're looking for the minimum. So my guess is if we extend this line all the way out here, that's going to be closer to a maximum, and I just want to find the minimum. So it's going to be one of these two vertices. Alright, so this is 0, 10, and this one is 1, 2, 3, and 6. So let's plug those in and see which one's going to be the minimum. So here, with x0, 10 is y, c would equal 80, right? Because 8 times 10 would be 80. And then this one, we have 3, 6, right? So if x is 3, 5 times 3 is 15, 8 times 6 is 48, 15 plus 48, so 5 plus 8 is 13, 5, 6, this is 63, and that one is 80. So what we would find is our minimum would be here. And that would be at 63. C would equal 63. So the process is pretty, it's long. You have to graph each of these, figure out